So, on page 86, we still have the properties that we've been dealing with. There is one new thing we're going to do today. Well, actually two things. One of them is brand new. The other one is not quite brand new. Is we're going to start talking about natural laws, right? And then we're going to talk about a brand new one is the change of basis. Okay? Because, for example, if I have the log base 2 of 5 plus the log base 2 of 7, I can condense this, right? What does it become when I condense it?
Log 12 log.
What do we do when we have an addition? We condense it. Okay, so then what do we get? The log base 2 of what? 35. Okay, now let me ask you another question. What if I had same thing here? What is it?
You can't, because the one parts are different.
How? Because they're not like terms, right?
Yeah.
The bases are not the same. So what we're going to do today is how do we then make this thing to look like this or make this to look like that? Okay? So we're going to do change of basis. Does that make sense? All right, so we're doing change of basis today because just like before, whenever we solve a quadratic and we ended up with like a -9 under here, we just wrote no solutions until we find out that we can write I. All right? So now today, we're going to extend this. Does that make sense? Okay. So the first thing I'm going to give you is a change of basis formula. Okay? People call it basis, people call it base, I don't know. Do what again? So, if I'm given a log, a base, and an argument, the change of basis formula tells me that I can change them to whatever base I want. So I can say the log base x of b over the log base x of a. As long as I have the b over the a. Because again, it's almost like if I drew a line here, this is on top, right? And this is the bottom of it. Okay? Now, because we're going to be using our calculators in this section, at least for the homework section, I can write this as something that the calculators allow me to do, which is going to be the log base 10 of b over the log base 10 of a. But that's not the only log button on my calculator. I also have the natural log. So I could either write this as the natural log of b over the natural log of a. That's an L. I got people still writing IN. Okay? That's the brand new thing for today. Okay? The one that is not so new is, if you remember, we had the log, right? Because the base was a 10. So we said the log, if the base and the argument are the same, our answer is just the exponent. And actually it was written this way: the log base a of a to the r is just r. By the way, let me ask you a question. What is the log base 10 of 10 squared? 2? Okay. Now, what is the log base b of b squared? Huh? 2. Oh, okay. Because I want to make sure, because people lost their mind on the test when I asked you for 3b squared. And you give me answer back with b in it.
So like, when you square it, do you just get rid of the letter?
No, as long as the base and the argument are the same. If this was a 3, my answer would still be a 3. If it was a 5, my answer would still be a 5, as long as these two things are still matching up. Okay? That is the reason why this thing here. And that's the reason for this thing right here. See that? As long as these two things are matching, my answer is the exponent. Okay? So we had this with base 10. The thing that is not so new right now is the natural log. Okay? If I have the natural log of e to some power, then my answer is just the power. So base 10 of 10 to something is just that thing. Natural log of e to something is also that thing. Okay? So this, you need to write. It's not too new, but it is new. This is the brand new one that we're going to work with. So there are a few calculators in here today because people took their acting test and didn't bring back my calculators. So those of you that have one, use it. Those of you that don't have any, hopefully you can share with somebody that got one. Okay? That is at least functional. Because I acted stupid. I gave out my batteries, and I thought I didn't need them anymore. Now I got a bunch of my calculators there, and I can't get anybody to give me batteries. So I'm gonna have to buy batteries, but we almost out the spring break. I am not gonna put it on for anything right now. Are we good? So those of you sitting close to the people with calculators, if you look on your calculators, there should be 2 buttons there that I want you to pay particular attention to. One of them says LOG, and the other one says LN. You see that? Okay. So those are the 2 bases that your calculator knows how to work in. LOG is base 10, and then LN is the natural log. You see those 2? They're right after one another on those yellow calculators that you have. And I think those of you that got cell phones, although I don't allow you to use them, if you open your calculators and lay the cell phone sideways, I think we'll show you those buttons also. Okay, now, let's look at problem number 1. Problem number 1 says we should evaluate these things using LN and LOG. Number 1A. Everybody pay attention because some of y'all lost your mind on the test. On the test, I give you values of the log of 2, 3, and 7. And I said find the value of the log of 18. And you were supposed to break that down into 3, 3, 2, right? Yeah, a lot of people don't know how to still multiply to get an 18. But I'm just going to leave that alone today because I do not want to lose the rest of my hair that's left on my head.
What?
So, 16. How do I break 16 if I'm given? Well, actually, they want us to find the log base 8 of 16. So, number 1. Number 1. Can we plug in the calculator right away? Do what? Can we?
Yeah, how do you even get the like, I don't know how to get the number under the, I was trying to do that.
And those are the questions I'm expecting because the first thing is, your calculator only works in 2 bases. Base 10 or the natural log, right? At least that's what it thinks, that it's not able to do base 8, but we can trick it into doing base 8. Right? It thinks it can do it, but we can make it do it without it recognizing that it's doing it. Just like I do to my kids. I make them do their chores without them thinking they're doing work for me. Because you know when you're a teenager now, you don't want to do anything just because the folks say you should do it. That part. So, I'm going to use the change of basis. Okay? So I need one person to use the natural log key and one person to use the base 10 key. Okay? And here's how we're going to do. So I'm going to say, I'm going to use the base 10 because again, I'm going to write it this way. It's the base 10 of 16 over the log base 10 of 8. Okay? One person should give me the answer to that part. And I need another person to say, well, we're going to use natural log. 16 over natural log of 8. So who's doing what?
I just got lost.
1.3 repeating? Okay, somebody said for the natural log. Who has the base 10 ready? Who did base 10? Just do log. If you're doing base 10, just press log 16 divided by log 8 and push enter.
.301.029995.
Are you sure? Check that.
What?
I got people pushing calculator by this. What's the different answers? No, not like that. That's not how it's written on the board, man. It's written as the log of 16, right? Divided by, there's also another log, the log of 8. See exactly like it's written on the board.
Yeah, I didn't look at the board. I just tried to listen to what you said.
Please, right, tap it like you see it on the calculator.
Somebody do it.
Somebody, take your time, put this exactly. Don't take shortcuts, put exactly like you see it. Yes, 1.333. You see how I get headaches when I grade your papers? One thing. Just push this in and people see something on the board and they put in something completely different.
This is a one-time thing.
No, not just you, but that comes through like a lot. I'm not pointing at you, it's like, it happens a lot. You still got a different answer? What are you pushing? Let me see what you can do.
Fuck.
Like what one?
I'm not.
Why don't you close the parentheses? You see parentheses on that open? Why don't you do it this way? Because the whole thing was not in one parentheses. So, while they're working on the calculator issue, let's get back in. Somebody said they're both the same. Yes, they should all be the same because here is the change of bases right here.
Yes.
It says I could use base 10 or natural log, I will get the same answer. So that you're not restricted to only one thing. The change of bases work whether you're using base 2, base 10, base 8, natural log. As long as you keep it consistent. Okay? Now, just for the fun of it, somebody check what is the value of the log of 2, not base 10 of 2. Log base 10 of 2. Just do log 2. Push enter. 0.1, 0.3. Okay, do natural log of 2. Enter. So it's not the same here, right? I don't want people getting here and be like, oh, I can divide, right? And get 16 divided by 8 is 2 and do the log of 2. It's not the same. You already see you're getting two different answers on it, right? This gives me 1.3 repeating, the other one gives me 0.3, which is one whole number less. So don't get here and be like, I can take shortcuts. We're good? Any questions? Okay, then I want you all to do problem B. Take 30 seconds and do problem B. Following my example, or our example, do problem B. Everybody. Go, 30 seconds. So everybody's saying now that some people use natural log, some people use base 10, and we all got the same answer, 1.2 if we round, right? Is that what everybody got? 1.2? What'd you get?
Huh?
What'd you get?
I didn't. I was trying to figure it out. But I was just about to do it.
So, put it there. So it's just the log of the top number. What's our top number? 11? So the log of 11, what's the parentheses always? See that? Divided by the log of the bottom, which is what? What's the bottom number? What's the base? 7. The log of 7. And then close the bracket on the jump. See here? Log of 11 divided by log of 7. Which enter. Okay. Does that help? Can we go back in? Because one of the biggest things to getting this right is knowing how to use the calculator, right? Why are you bothering her? She don't want to be with you. Leave her alone. So C. Log base 3 of 2, guys. Just because he passed your first test, don't mean he's not disrupting my room. I'm gonna look at you. Who? I am not proud of you. I'm not allowed to. Okay. We ready?
You don't even know real pain. You don't even know real pain. Let me show you.
So I already got somebody telling me they look the same except the basis and the argument are swapped around, right? And we can't do anything right now because we saw that from the beginning, right? So all we got to do now is to say, well, in order for us to multiply, if we want to put the bases together, we have to do change of basis, right? We got to do change of basis. So what I'm going to do is I'm going to change this and then also change that. Okay? And then individually add them up. So this, what do you want me to use? Natural log or log base 10? Where's he going?
I forgot about the calculator.
Oh, okay. So we should use log base 10? So the log base 10 of, no, it doesn't matter.
Bro, it didn't happen when I was here.
You have to use the same for both top and bottom.
And both sides?
Well, yeah, we could do that too.
Oh, okay. So it doesn't matter which one you use?
No. Because as long as we keep it consistent, right? Because we want values. So we want to be able to use log base 10 or natural log, right? Because those will give us points. So plus log base 3 over log base 2, right? We could do it this way. Okay? Now put this in the calculator. So this and that. So what is the value you get here? And you calculate those people.
So you look a little cute.
0.630.
0.63. Okay, let's do that. And then what do we get here?
1.58.
1.58? Okay. So add these two together, and your answer should be Jackson.
2.13.
There you go.
Dude, I literally wrote it down and just said it. Only smart with something. Some things I can just say.
What's the answer?
It's being 1.3. Is that it?
Hmm?
Is it good?
Yeah, if you add these two, whatever you get. You get 2 point what?
1.3.
Yeah, it looks like that.
Looks like.
Yeah, it does look like it. That's why I said it. You're not trusting my brain?
No, that's a bit.
Okay. Problem 2. Problem 2 gives you values. Just like I gave you values on your test, I just gave back to you. Problem 2 gives you the value of the natural log of 2 and the natural log of 3. And now they want you to expand those things and find the values that are given to you. If you remember, the not so brand new thing I wrote here, I said that the natural log of e to the x is just x. Okay? Because the natural log in e got that special relationship. Just like base 10 of 10 to some power got that special relationship. Okay? Just like base b of b squared is 2. People stick up a b on the log base b of b squared. And they wrote like the craziest answer for me.
Sorry.
Okay. So 2a, what would be the answer? 4. Why? Because of this property right here, right? Because we're looking for the natural log of e to the 4. Are we good? You see that again, you're not going to write craziness, right?
Oh no.
I know no guarantees, I'm going to leave that alone. Let's do C, because I did C for your cousins, and then they had to do, so problem C. Problem C is asking us
Oh my
for
God! You always want to hear something.
the natural log of 108. Hey folks, pay attention. The natural log of 108. We are given 2 and 3. So we need to prime factorize 108 into 2s and 3s. Okay? Michael Jackson, remember the time you were in 2nd grade and you did factor trees?
Oh, yeah. 9.
All right, so 2 and 54. You're not buying it? She said, yeah, sure, whatever. Same thing I was going to tell you, yeah, sure. 2 and 27, 9 and 3, and 3 and 3. So this thing prime factorizes into 3 cubed and 2 squared, right? Okay, so the natural log of 3 cubed and 2 squared. Just from here, here's my 2 squared and my 3 cubes. Oh, you weren't here to see him fall. Took him about 20 minutes to get off the ground. You missed out on it. Okay. Now, we can write this, whenever we multiply, we can bring the things into addition, right? So we can do that here also. See that? Just like we did with regular logs. Now this is an exponent.
Bless you.
Okay. So we can write it this way, right? Are we given the value of the natural log of 3? Yeah. So whatever that value is, I think it's 1.1, right?
1.10.
And are we given the value of the log of 2?
0.69.
0.69. See that? So we just multiply. This is a 3.30. And what would that be? What's 2 times 0.69? 1.38, and then add up these two, and that would be your answer. 4.68. All right. How do I get what? You find it? You sure you found it? No, you didn't. What was your question? So I did 3 times 1.1. So 3 times 0 is 0. 3 times 1, 3. 3 times 1, 3. That's 1.6. Are we good? Everybody see that? Okay. So now I need you to take 1 minute and do problems B and problem D. So 2B and 2D. How you going to break 2B up? Into what two numbers? Okay. And then problem D is going to be it's going to be what kind of thing we're going to do? Are we adding in problem B? So we're going to be subtracting, right? Okay, everybody take a minute. Do 2B and 2D. Yeah, 30 seconds for each.
This is my life.
Are we ready?
Yes.
All right, 2B. Let me hear some answers.
1.79.
I got a 1.79. Anybody got a different answer for 2B? You got stuck where?
My word.
So what did you break the 6 into? What? 3 and 2. So you had the natural log of 3 times 2, right? If it's a multiplication, how do we break it up? What does it become when I get these things? What goes in? Huh? Yeah, addition. So what is the value of the log of 3? Are you giving the natural log of 3 value? And the natural log of 2 value? We're just supposed to put those two together. Okay. Are we good? Okay, now I need somebody else to tell me D. What do you get for D? Somebody else. Huh? Somebody else. What do you get for D? 0.97. I got a 0.97. Anybody else?
1.66.
1.66. I got 0.97. 1.66. Anybody else?
Hold on, wait, give me a second.
1.89. 1.89. 1.66. 0.97. Anybody else?
You sound like that guy.
1.9.
Out of Usher.
Is not
Did somebody
right.
already say 1.9?
Instead of doing too cute, I just
Did somebody already say 1.89?
1.89. Somebody risk 1.89. Okay, I got a 1.89 here. All right. Anybody else? Because I got somebody taking back there. Are you taking that back?
Yeah.
No, yeah, she's taking it back. She dropped one.
I can't.
Okay. So I'll take anybody else?
Yeah.
Okay. So you had to do subtraction, right?
Yeah.
So, so we're asking for the natural log of, what's that? 8 thirds.
I got 0.97.
Okay, which is the natural log of, what am I writing?
That one was pretty good.
The natural log of 8 minus the natural log of 3, right? But do we know what the natural log of 8 is right now? No, but we can break that down, right?
Yeah.
8 is 2, right? Yeah.
2.
So the natural log of 2 minus the natural log of 3. So there are some people who like to do the natural log of 2 plus the natural log of 2 plus the natural log of 2. That's fine, right? This is the same as 2 to the third, just like we did here. It becomes 3 times the value of the natural log of 2 minus the value of the natural log of 3. So this is 3 times whatever this thing is. What is it? 0.69 minus 1.10, right? Didn't we already multiply this before and got a number? What was the value? Oh no, we haven't done it through. We did it just twice. So what's 3 times 0.69? 2.07 minus 1.10. So here is the question. I walk up to your register, you're a cashier, and I'm buying something worth $1.10, but I give you $2.07. What's my change? 97?
Wait, what?
He wants to hear the question back. I walk up to your register, and I buy something, and it's $1.10, but I give you $2.07. What's my change? Oh. Would that be right though?
Yeah.
Okay. Calculator says so. Oh, I'm just checking, because some people,
98. It's 0.98. Tenths, hundreds.
Is she still checking?
Thousands, millions.
Why are you doing that?
Trillions,
No, we're not looking
quadrillions.
for that.
100 millions.
Okay, number 3.
Okay.
Number 3. Number 3 is now asking to compare the values of the log of base 1/9 of 10 without using calculators to the log base 9 of 1/10. Oh, by the way, before the bell rings, your homework is going to be 6, 7, 8. Just so you know. So
6, 7, 8.
let's do number 3.
You already did
You
it.
already did 6, 7,
You already did 6, 7, 8.
You were mad that day.
Yeah, you remember you
Yeah.
did it.
And then you gave us 9 for homework.
Yeah, then that means you already know what your homework is. Your cousins are just doing that, but I'm guessing you didn't know how to do that. So you might want to check back at it now that you know how to change base.
You didn't even do it so well.
Get after it.
Okay,
6, 7, 8.
number 3.
Oh, we're not. Where is it?
What do I have? I have log base.
1 over 9 to and 9 over 9 to.
So let's do this first. I'm going to do this. Hey folks, change of base is what I'm going to do. because they want me to compare that to the log base 9, right? So I'm gonna write this as the log base 9 of 10 over the log base 9 of 1 over 9.
How did you change the one over?
Change of base. Change of basis formula. I just chose base 9 instead of base 10. Change of base, I can use any base.
No, no. Why,
You'll see as it goes on.
like you saw.
Okay, so this is the same as the log base 9 of 10 over the log base 9 of 9 to the negative 1. Right? Now Michael Jackson, right? If these two things are the same, my answer is just the exponent, right?
Yeah.
So if these two things are the same, what's my answer here?
-1.
So this is negative the log base 9 of 10. Right?
Yeah.
So that's what we get for this piece, right? Now let's compare that to the log base 9 of 1 over 10. We have a property that says the log of anything is just 1 over that thing, right? Whatever base we got. So we're gonna write this as negative. Are these two things the same?
Yeah. Yeah.
That's good. That's good.
Number 4. Number 4 want us to show. Every time that they ask us to show, is they want us to show. Show me your work. Show me how we get here. Prove it. Let me see. Okay? So they want us to show that the log base A of B. By the way, in problem 6, when they ask you for it to contain base 10, they want you to change these bases to log base 10. Okay? Change everything here to log base 10. And then number 7 is the natural log, so change them to natural log. So you don't change your bases in those problems. So they want us to show that if I have a log base A of B, and I multiply that by the log base B of A, I should get 1. That's what they want me to show. So let's show them. First thing, Mr. Reich told us that we can't multiply this from the beginning because they didn't have the same basis, right? So in order for me to do that, what I'm going to do is I'm going to say, let me change the log base B and see what happens. So I'm going to change this side to log base B. Change of basis, say I can do the log base B of B divided by the log base B of A. I can pick any base and then just put it in. I still have this thing on this side, right? The log base A, I mean base B of A is 1. Still got, if I multiply, I should get it. What's the power on this B?
1.
Okay, 1. So from our test, we had log base B of B squared, we said that was a 2. What is the log base B of B to the 1?
1.
1, just the power. So this thing gives me 1 over the log base B of A times, I want to check it that it's still 1. See that? This is a fraction is over 1 if you want to do that. So now I just got something divided by itself. What's anything divided by itself? What's 5 divided by 5? Yeah, anything divided by itself is 1. So I got 1 equals 1. Is that a true statement?
Yeah.
Always.
I don't know how it cannot.
I'm available on the North Campus today from 209, Ms. Bath's room. I'm there at 3. Please make sure you're checking out the YouTube channel.